This ball on a string has all the characteristics of a simple pendulum. It has a very light string, a bob with minimal surface area, and a small amplitude of motion. A simple pendulum is entirely deterministic. That means that its behavior is completely predictable based on initial conditions. If you know the string length and the initial position, you can predict where it will be any time later. A good way to demonstrate this is with two identical simple pendulums. If they are released with the same initial amplitude, they will stay in rigid time with each other as they undergo their motion. This is a double pendulum. It is a simple pendulum hung from another simple pendulum. The motion of this device is much more complicated. There are two gravitational torques acting on the bobs, as well as two tensions acting on the middle ball. The behavior of this system is not exactly random, but it is very unpredictable. Any slight variation in the initial angle of either string or the position of either ball will have dramatic effects on the evolution of the system. Such a system is called chaotic. Here we have two double pendulums side by side. I'm trying to make the initial conditions as similar as possible. Here goes. You can see that even after just a few cycles, the two pendulums are out of phase with each other. Here's a computer simulation of the behavior of a double pendulum made from two connected rods. The computer will trace out the motion of the tip of the bottom of the rod. You can tell by which areas get colored darker where the pendulum spends most of its time. Here is a still frame of a long exposure of a real double pendulum that has an LED light attached to its bottom tip.